Good evening, students. Today's our topic is electricity. Let's discuss about introduction of electricity. Do you recognize the person you see on your screen? Yes, he is the great Thomas Edison. Do you know that what he is known for? In 1879, he invented the first practical long life elastic electric light bulb. Since then, our homes are bright even after sunset. You must be aware of the fact that light in our home bulb on electricity forever. They do not. The only that used electricity are television, air conditioners, water heater, fan, and so on also need electricity to function. Laser light or even small flashlight is also work on electricity. Imagine our life without electricity in the world today. The discovery of electricity has helped to start a new revolution in the history of humankind. But let's just keep aside all the rhetoric talks and try to understand the real thing. I haven't really told you what the term of electricity means. Well, the basically two forms of electricity. One is static electricity and the other is dynamic electricity. For now, we only interested in dynamic electricity. Dynamic electricity. From the name itself, we can say that the implies moving electricity or move precisely moving electric charges. And next question you have, what are electric charges? The concept of electric charge is a very important in physics and can't be explained a video audio, but I will still give to try assured to the point of explanation to the concepts. So let's begin. Two types of electric charges: positive, to noted by a plus sign; negative, to noted by a minus sign. Think of magnet for a movement. We know two likes poles, that is two north or two south poles, repel each other, and unlike poles attract each other. Again, we know two like poles, that is two north or two south poles repel each other and unlike poles attract each other. Similarly, light charge, that is two positive or two negative, once repel each other and unlike poles attract each other. But what exactly is charged, or another word, who actually carries these charges? Well, these charges are carried by tiny particles with incredibly small mass called subatomic particles. The positive charge is carried by particles called protons, while the negative ones are carried by particles called electrons. There are billions or trillions protons and electrons present in any object around us. In some objects like metals, electrons can move randomly, while a non-metal their positions kind of fixed and hence they can't move freely. Now any appliances in our house, for example, or tube lights, works because the negatively charged electrons are moving on wire in one direction. This unidirectional motion electron in a wire is also called electric current. These wires are made of metals, usually copper or aluminum, and you can understand why. But why are charges in a wire moving in one direction, or what makes the charges in move in the wire? The charges move in the one direction in wire because of the energy supplied to them by the transformers. So the transformer supplies energy, the charges move in wire, which in turn makes appliances work. A flashlight also works same way, but here the energy is supplied by the two electric batteries. So the submit all are in dynamic electricity. How to electricity charge through conductors like say copper wire? Generally, when we talk about electricity or electric current, we mean dynamic electricity. Hence, we simply say that electricity is nothing but the flow of electric charge